Okay, so this is OWASP top 10 like I'm 5. So let's just start. So who am I? I am probably very nervous right now reading this because this is my first talk ever. So yeah, I expected to be nervous, but it wasn't on this level, but it probably will get better. So I am also making a YouTube video about my experience of doing this, my first ever talk. So I tried to do some kind of a video afterwards about going from zero to doing an actual talk. So yeah, that's gonna be interesting. Also, it's super hard to walk around with like a big camera like that. It's super difficult. So yeah. Also, I'm a bug bounty hunter, web developer, and a high school student. Also, I'm a 2018 Bug Crowd MVP, so that's why I'm showing off my T-shirt, which no one can actually see, but it's yeah, I never wear that before. So, and I'm also a co-host of the podcast named Insecure Space with Space Han. So you should check that out. I'm just starting a timer here because I'm gonna mess it up later. So here we go. Yeah. So for questions, I'm trying to do a different approach. So there is like a thing called Slido, which is a web app where you can ask questions. You can just open it in your browser. So if you go to slide.do and enter the event code here is OWASP. I'm pretty lucky to have that name because, but if you enter the code OWASP, you can ask questions and we will see that later. And you can vote on other people's questions. So it's probably way better than just trying at the end of the talk. So we will look at Slido later. So ask your questions there. So what is OWASP Top 10? So OWASP stands for Open Web Application Security Project, and OWASP Top 10 is a list of the top 10 most critical web security risks today. So it's made to help developers and pen testers understand and defend against these vulnerabilities, and it's also a bit dense and could be hard to understand at first. So my goal with this talk is to make it a bit more easily understandable, hopefully. So here is the list, the top 10 list. We are going to go through each of them one by one. And the talk structure will be like that for every bug or like list item, there will be 3 slides, not 5, because I planned to do 5, but then I realized that there's no way it's going to fit in 40 minutes. So I had to delete all of that. So we are only going to do what is it, what's the impact, and real world examples. So let's just start with A10, insufficient logging and monitoring. Now, this is not as exciting. Yeah, it's kind of boring, but let's just go through it. So it's about having no or improper logs, crashes that don't generate useful logs are not monitored, and basically having no bad or not enough logs that, and not monitoring them. So severity on this one is kind of low. So because, the impact of this is that you can't see if someone is trying to attack the app. So if you don't have logging, you don't see people attacking. And if attackers get in, you won't notice them. So this can lead to further exploitation. So, for these examples, there are no real bug bounty examples. There was a Yahoo breach, which, got discovered in 2016, and they hacked Yahoo at 2013. So it took 3 years, and because they didn't have like proper logging setup. So there was some Marriott International, the hotel site. They also got breached in 2014, and they discovered it in 2018. So that's also kind of a big leap there. That was logging. So A9, using components with known vulnerabilities. Okay, it's still not, it's nothing really technical. It's just about using software which, with known bugs. So not updating software with known vulnerabilities. And the severity of this, it depends on the type of bug we are talking about. So it can be pretty low or pretty high. So the impact, is that if an attacker scans your website, it can find, like version numbers. And if it finds vulnerable versions, if there are, you can use pre-written exploits, or depending on the vulnerability, it can also compromise like other systems maybe. So real world examples here is the Equifax breach, for example, which was because of an Apache Struts vulnerability. And also there are some, IoT botnets which use also a lot of already known bugs, but they don't patch it because it's IoT. So, for example, Mirai botnet was like this, that it uses a lot of well-known exploits, also brute forcing, but a lot of exploits to target unupdated IoT devices. So yeah, these were pretty boring. So let's just try the A8, which is insecure deserialization. This one is a bit more technical. So first of all, what is serialization? It's turning an object that you have in a programming language or like an object to text, which you can transfer. And after that, using that serialized object in cookies or like hidden forms on the site. So you're basically sending the object by the browser. And the severity is pretty high on this one because the server deserializes it upon receiving, and this can go quite wrong. So here's an example. I'm going to use my fancy pointer thing. Can you see it? Pretty cool. So we have a PHP object here, and if we serialize it, that's what we get, a PHP serialized object, and that's a string, and PHP can convert it back to an object. But if there's an example attack scenario here, it's that if we, for example, if this is a cookie, for example, and if the attacker changes the cookie, notices there is user in the cookie. Okay, what if I change it to admin? When the PHP parses the cookie and converts it back to an object, it's going to convert the admin back, and now the attacker is going to have admin permissions. So you have to be very careful with sending objects which are, serialized. So there are two kinds of attacks on this one: the data tampering attacks, which I just showed an example of, and it can be access control, like changing it to user to admin, or a lot of other bugs if there are no validation. It can be injection or anything that we will talk about later. Also, there are object-related attacks, which is like crafting a payload that uses available classes which can perform actions when deserialized. And with this way, you can get remote code execution RCE, which is a pretty critical, one of the most critical things you can get. And this is super complicated. I personally have I tried to research it, but it's really hard. So fortunately, there are tools which are pre-made to do this, like JSO Serial and Java Serial Killer. These tools generate you an object, a serialized object that you can send, and it's gonna just execute the command, if you're lucky. And so real-world examples. There was a remote code execution on a PayPal server. There was a blog post by Michael Stepankin. So this is about it. So there was a post parameter named old form data that was a serialized Java object. And using the tool named JSO Serial, Michael created a proof of concept object, and which when deserialized by the server, it sent the content of etc password file on Linux to Michael. So here we can see the attack. So there was, use my fancy pointer again, he noticed the old form data is a serialized Java object. So then he generated a RCE Java object which executed a command when deserialized. And then he got back a request from the server because he made a request in the command. So as you can see, he executed code on PayPal server and he got back a response to his server. And even he could also leak the etc password file, so he could basically just get remote code execution on PayPal, which is pretty nice. So the next one, A7, is cross-site scripting. This one is running malicious JavaScript in the victim's browser in the name of the site. So it is mostly caused by user input not being escaped and echoed back into HTML. The severity, medium, depends. I don't know, you can argue about it, but there are pretty high impacts of it as well. So here's a basic reflected XSS. So there we have a PHP app here which just says hello and uses the get name parameter, and echoes it back to you. So if we say hello and we put the name David, then it says hello David. So but if we put name script alert 1 closing script tag, so HTML script tag, then it's going to echo it back to us. So it's going to say hello script alert 1 script. And the browser thinks, oh, that's JavaScript. So it's going to execute the script in there. It's going to show us a pop-up. So we can execute script on the website in the name of the website. So there are three types of XSS, reflected, stored, and DOM. Reflected is non-persistent. It's reflected from something like a URL, for example, what I just showed. It affects only the user clicking on the malicious link. And the stored XSS is a bit more, it's persistent like a malicious comment, and it affects every user who loads a page. So, for example, you make an XSS on a forum in a comment, and everyone who looks at the comment is going to have the script running. DOM XSS is something when a payload is not reflected into HTML directly, but executed by JavaScript on the page. It's a bit more difficult to find and test for. So what's the impact here? The attacker can perform actions on the site in the name of the user, steal user session cookies, redirect users, modify the page for the user, anything that you can do with JavaScript. And, for example, let's just give an example here that you can make a phishing pop-up asking for the victim's password, or if it's a news site with the stored accesses, you can maybe modify news articles or something. So anything that you can do with JavaScript. So one example here is a Steam chat client XSS which lead to an RCE. I'm including these report and the ID paths. You can go on these pages by using https hacker1.com and the URL here. So these are HackerOne URLs. And it's paid $7,500 and it's an amazing write-up. So you should check it out if you're interested. It worked like that in Steam you can use this BB code thing where you, for example, specify a URL and you put some text with it. And if you, for example, put URL, google.com, click me URL, and then it's going to make the click me a URL to Google, like a redirect to Google. But he put JavaScript alert1 into a URL. And this is called the JavaScript URI. So you can, if you redirect to this JavaScript URI or you click on it, it's going to execute. So, Steam chat client generated a link to JavaScript alert1, and if the other person clicked on the link, alert1 executed. So accesses on the other person's Steam website or client. And he also converted it to RCE with like a fancy exploit of the Steam protocol, which I'm not going to go too detailed into, but the accesses part was relevant to the talk here. Okay, so A6, the next one, security misconfiguration. This can be basically anything which is misconfigured. For example, improperly configuring AVS bucket permissions, crash trace exposes secrets, and password is not changed from the default, anything like that. And the severity again depends on what kind of issue we are talking about. But what is the impact here? Because, we don't know, it can be a wide range of bugs, basically. It can range anything from, low severity stuff to remote code execution. There is one really interesting, but it is a Snapchat Jenkins RCE. So it paid $15,000, which is quite a lot, and it is basically about the Jenkins server, which Jenkins is like a server which companies use to run and build software and like do continuous integration stuff. But, you could usually log in there with like a Google account, but the Google account has to be from a Steam is from a Snapchat account. So you have to, only Snapchat people can log in. But with this one, everyone could log in. It doesn't matter if Snapchat person or not. So any Google account could log in. And in the Jenkins, there is a thing called the script console, which is basically like an icon. I don't know. It's like a terminal. So you can execute commands there. So he got RC, remote code execution, that way. Okay. A5, broken access control. Yeah, I think this is my favorite type of bugs, because I found most of my bugs, most of the time bugs I found are BAC, so broken access control. When an attacker, it's about when an attacker can perform view edit stuff, which he or she shouldn't. So, for example, basic user can perform admin only actions, or like an attacker can access other user stuff. You'll see an example here. Severity again depends, you can't really tell. So here's a simple IDOR example. IDOR stands for Insecure Direct Object Reference. So here we see a normal request. Attacker has an ID of 2143, and he makes a request to the API asking for the user details of 2143. So this is normal, right? And he gets back the attacker his info, like credit card number, address, everything. But what happens if an attacker tries to request some other ID? Maybe if the app is not well protected, the other user's data is going to get back. So he's going to get back the details of the other person, so the credit card number and address. So, depending on the situation, this can be pretty severe. But, IDOR can happen on a lot of places. So what is the impact? Depends again. So you can modify the data of other users, perform sensitive actions without having permission, access paid features without paying for it. That's that's one that usually companies, or I, in my experience, a lot of companies don't pay attention. So they put like a paywall, and then, you have to pay. Otherwise, the UI on the buttons are grayed out on the UI. You can't press them. But if you repeat a request which turns on a paid feature, usually they don't check if you actually have a paid account or not. So that's something to keep in mind. And also basically anything that you can do even though you shouldn't able to. So that's broken access control. There is one example, really cool. It's the Steam CD key IDOR. It paid $20,000, which is especially, it's a lot of money. So it was about an IDOR on a partner there's a Steam website where people can publish games, where they manage their games. So there was an endpoint which generated CD keys, and you pass the ID of your game, and it gives you back a CD key as usual. But there was an issue that you could pass in any kind of game, and it gave you a Steam key for that game. So you could just get a Steam key for every game on Steam and sell it if the attacker wanted to do that. So that has a high impact as well. Okay. A4, now we are getting into higher priority ones. This is XML external entities, XXE. This is pretty interesting in my opinion. So here, if an app uses XML to send data or accepts XML file, uploads it or processes XML, it uses an XML parser to process the XML. So if the XML parser has external entities enabled, the app might probably be vulnerable. Severity is really high because this have a big impact. We will see here in an example. So I hope you can read the code, by the way. I try to make it really big, but not sure. So here is the example. We have a basic app. This is from a blog post by Authentication.com. It was really great. I just kind of used their examples, so that's why I'm crediting them. So here this web app does is you send an XML with a foo parameter, and it just gives you back what the foo parameter is. Pretty easy. So you send hello world, it says hello world. Now, in the second one, we set up entities. So we set up entities like a variable in a programming language. So, for example, you set a bar variable to word, and then you say hello and the bar variable. What does it translate to? Hello world. So you get that back. It's pretty, nothing dangerous here. But what happens if you specify an external entity? So you specify like XXE entity, XXE variable, and you name it a system variable, which is an external variable, and you give it the path file etc password, and you put it in the foo parameter. So the server says like, okay, I need to echo back the variable. The variable is etc password file, so I just read my etc password file and echo it back. So, and now you can read any file on the server. So what's the impact here? Attacker can read files on the server, perform SSRF, server-sided request forgery attacks. It's just about sending requests from the server. It's when you make the server send request to where you want it. So you can scan local networks with this as well. So for example, you can send requests like this to like a local IP like 10.0.0.1, and if it takes a long time or XML parser crashes, maybe there is no such host on the local network. But if it gives you back some kind of HTML or some response, maybe there is one device. So you can just like scan your local network as well and like pivot, which you shouldn't really do in a bug bounty situation, but that is also possible. And you can also perform denial of service DOS attacks here, for example, by reading on Linux the file dev random, which is an endless file. So if you try to read it, XML parser tries to read it, it's just going to read, and it's going to fill up and it's going to crash. So that's denial of service. And in even rare cases, it can lead to RCE, remote code execution. So that's why the severity is pretty high on this one. So, real world examples here. We have a Twitter XXE, which paid $10,080, not sure why the 80, and it was an XXE on the HXMP processor on a Twitter web server. So, here's what the attackers sent. As you can see, he declared the entity, external entity here. So he put file, and it's a file on the system, etc password. And what he did is, at the operator ID parameter, he referenced the file. So that's the request what he sent. It was a basic post XML request. And what he got back from the server was an error that, oh, I'm unable to convert and the whole Etsy password file to an integer for operator ID because operator ID needed an integer. So the error message exposed the whole file. And with this, you can read any file on the Twitter server, which is bad. So there was another one, Pornhub upload server XXC, which paid $10,000. I included this because this is not just an XXC. This was a bit more complicated than that. But, you know, think about it. Read any file on a Pornhub upload server. You can decide the impact of that one. So, yeah. A3, sensitive data exposure. Okay. So this again includes a wide range of bugs. So it's not like an XXC where you have one technical bug. It's a lot of bugs. So these bugs are all about exposing data, for example, by not encrypting the communication, maybe not using SSL certificates, or like using old weak crypto, or like storing sensitive data like passwords in clear text, which you should never do, and accidentally exposing secrets and keys, which, you know, happens more often than you would expect. So, and, you know, everything else that can expose sensitive data. So the severity is high on this one. So what's the impact here? If these security practices are not in place, an attacker could, for example, there are no SSL certificate, then you can perform a man-in-the-middle attack and capture data while it's going through, for example, a public Wi-Fi network. Or you can, for example, steal all unencrypted passwords if they are not hashed correctly. So if someone gets access to the database, if it's not hashed, you can see everyone's password, which is terrible. And also, you can access internal systems, for example, by finding unintentionally exposed secrets, which we will see a real-world example of. So here's Snapchat token leak on GitHub. Now, it paid $15,000, which is again intense. So it was that Snapchat they had a public GitHub repository where they pushed, you know, their code, their open source code, but someone accidentally pushed an API key to GitHub, which gave them access to their private, other private server. So as you can see, the GitHub, they leaked the token for GitHub sccorp.net. So that was their own server. And, yeah, there is no image for that one, but basically what they did is just accidentally, you know, committed that code with the token in it, and you can just reuse that token and then get access to the server. So, and this happened quite often, you know, yeah, there are even tools to detect this. There is a tool called GitRob. I had to remove the slide because it took too much time, but there's a tool called GitRob, which is made for just this purpose. So it just scans the GitHub repo of one company and sends for commits where they use like secrets and tokens. So there are like already tools built for this one. Okay, so there is also broken authentication. This is A2. Now, what is it? It's again not really a technical bug, but a collection of bugs using which an attacker can bypass the authentication. So, group of bugs include, you know, just first of all, let's note that authentication is not equals authorization. So the IDOR and the authentication is a completely different thing. Authentication has to do with logging in and stuff. So, this type of the group of bugs include like having no rate limiting, which, for example, can make brute force attacks possible. Also, it can be like allowing weak passwords like admin, or, you know, does not properly invalidating session IDs. So like, you know, if you log out, the session ID is still valid, which it shouldn't be. Or if you don't use the session ID for like an hour or so, the session ID should expire. So you have to log in again. So, giving different responses, for example, if the user doesn't exist. This is called user enumeration, which can also happen if, for example, if you log into an application and it gives you an error like, oh, this user does not exist. That's bad. It should give you an error like this user or password combination is not correct. Because if it gives you an error like this user does not exist, then this essentially means that you can just put a bunch of like a bunch of list of email addresses in there and see what users are registered in the app. Because if they exist, you get the error that this user doesn't exist. this password is incorrect, but if they don't exist, then you get another error. So you should give one type of error, for example, like in a login situation or everywhere. So you shouldn't expose stuff by giving two verbose error messages. What is the impact here? Like the attacker can get access to accounts. So it again, the severity of this depends on like what kind of accounts. Admin or basic user, or like what actions can the user perform, or what sensitive data is accessible. So the impact is basically bypassing the authentication. So it can be anything above that. These are really, it was super hard to find basic bug bounty examples for this because, people are not reporting stuff like there are security questions. Like security questions are unsafe, but you don't report them to bug bounty program. Bug bounty is a bit different, more of a technical thing. So they usually like these reports better. And what I found, which was kinda considered broken authentication, was a report by Mongo, which paid $10,000, which allowed him to change the password of any Uber user just by using their phone number, which is a pretty big problem here. So let's just see. So that was the data he sent. There, when you open the application, the iOS app, it sent a request to this passwordless sign-up thing, where you just enter your phone number and then it registers you or something. It was along the lines of this, but there was an issue that if you enter a phone number of someone else and then you enter the new password, then it's gonna say, okay, succeeded, new password has been created, please log in with the new password. But you just changed the password of someone else, and you can just brute force a lot of phone numbers, or I don't know, but this is still a really severe bug because just by the phone number you can take over anyone's Uber account. So, and for the last one, something a bit more exciting, which is injection. So injection is usually happens when the user input is not sanitized or validated. So for example, user input is used in an SQL query or a command which is executed on the system, or for example in a templating engine, so that injections can happen basically anywhere. So for example, a malicious user input can break out of the SQL injection, of the SQL query, and then execute something malicious. The severity of this is really high. This is the first one on the list, so that's why it's A1. So it's pretty severe. So let's see an example here. Okay, SQL injection here. We have a very basic PHP app which gets the post ID by looking at the ID in the get parameter. So this has an ID of 53, and then it generates a query by putting select from post where post ID, and it appends the post ID. This seems pretty fair, right? You put 53 in there, and then it makes a query like select from post where post ID is 53. This is okay. This is not a big deal. But what happens if you put ID equals 53 drop table users? The server is going to add the drop table users to the query because it doesn't care about it. And then the query which is going to run on the SQL server is going to be select from post where post ID is 53, and also, by the way, drop table users. And you don't want that probably. So what is the impact here? This is give you full access to databases, or like remote code execution if you have a command injection, or not sure what else to list, because these are pretty much say it all. It's really high impact. About a bit of a remote code execution here. For example, if you have a command injection, then you can just put like the end character or the pipe character. So to exit the current command and execute something else. So it can happen not even only on SQL, but also on other like commands or like other types of injections. Anything can basically happen here. So here's the real world example. There was a Steam SQL injection. It paid $25,000, and guess what? This was the same guy who found the Steam CD key bug, which I told you earlier. So he kind of made like 25,000 plus 20,000, which is not bad. It was about an unvalidated parameter, as you can see on report xml.php page, which could, be used to read certain SQL data from a single backing database. Yeah, I just read that. So it was basically like an SQL injection. Okay, thing is that I was probably a bit too fast with this, but I don't think it's a problem because we're already a bit late. But if I was fast enough, we should check the slide, or if we have any questions. It would be pretty lame if I don't have any questions, so I hope some of you at least ask the question. We will see. Let's just check. Okay. So, that's the okay. So at least I got one question, right? What was the most interesting bug you have found? I think it is still, which I have a bug which I found, which is still not, it's triaged and it's still not confirmed, and I'm waiting on it, and it's the really, really great bug which I'm trying to release, but I can't talk about it because yeah. But on other bugs, I usually find bugs which include, like, what I said, broken access control. So, hello. Can I? Oh, I can scroll. Okay. I usually find broken access control stuff. So you can, you repeat requests from one user, and on the other user so with one test account, you capture all the requests, and the second one you repeat it. And if you can access stuff from the test account 1, then that's pretty bad. So that's one bug already. So I usually test these kind of bugs. Do you consider doing bug bounty as a full-time job? No, because I'm a high school student, but that's a tricky question. Bug bounty as a full-time job is really, really stressful. That could be for another talk, because bug bounty can be really hard if you are really, really dependent on it. So, for example, in my case, you have to wait, like, for example, months until your bugs get, resolved. So if you really depend on doing bug bounty as a full-time job, you may have, like, a really bad experience. You're just stressing out that, oh my God, these reports are still not getting paid. So what I think is the best thing to do if you're just starting out, or not like the best bug bounty hunter ever, is to have a real job and then do bug bounty. So try to balance it, because doing it full time can be real hard or real stressful. But there are some people who are doing it, so they can make a lot of money. So it's certainly possible. Are you using scanner or automated tools, or is it just a waste of time? If the tool is like a pretty basic, or like something which everyone else uses, then it's mostly a waste of time. I'm sorry, but if you run these basic web app scans on a bug bounty program, you're just not gonna find anything, probably, because everyone can run that. So what you should be focusing on maybe is try to build your own tools, and try to build like something which is something unique to you, and then no one else uses. So okay, I'm getting anonymous questions again. Automated tools can be pretty good if they are applied in a good way. So it's not just you're using some basic scanner which is not going to give you any results. Can you DDoS this? I'm not sure. I'm not running this slide, though it looks like a big company. Wait, what? How did we get? Oh, you're upvoting stuff, and the order is changing up. So, great first talk. You're also a gamer. I can't send XSS to this screen. I don't know. What? There was a gamer question. I'm not really a gamer. I used to play games, but I'm not really. I kind of try to do some bit more productive, or but you can usually play PUBG for a few minutes, hours. Chicken. Let's see, I'm talking. Okay, let's DDoS. Oh, someone is DDoSing. Okay. Alert hi. That's not gonna work. You forgot the script tag. Chicken. BSidesBUD drugs. Yeah, agree. Have you used beef on XSS once? No, but that's a really great example. If I can talk a bit about, that's blind XSS. So blind XSS is getting an XSS without actually you seeing it. So it can be pretty interesting. So, for example, there was a bug, I think, maybe it was on GoDaddy or something, where at the support form, you can make a support ticket. And the guy put a blind XSS payload in the support ticket. And like, I don't know, a few days later, he got an XSS response back, because on some other web application, his ticket got into, like a lot of systems there, and some application didn't escape his script tags or like his payload. And then it executed on like an internal someone's system. And you can also make like blind, you can also make like blind XSS attacks, which is by, exploiting something which can maybe take time. It's really hard to explain without examples. If you're interested, blind XSS is something really cool, and you can use Beef to do that. Oh, okay. That's cool. Yes. Oh, I accept. Thank you. What's your biggest success in bug hunting? I don't know. It really, one thing I can tell you that is when I was, I was doing bug bounty I started doing it, I thought there is no way I can, just do this. There is no way I can find a bug. And I tried to do it a lot, and in like few months. So first I started on a point-only program, because that's where you don't get money, you only get points, and it's way easier because not a lot of people are attacking it. And then I thought, okay, I'm just gonna go for the paid ones. Why not? And I went to the paid ones, and I thought, no way I'm gonna get a paid bug. And I did it for like 1 week straight. I thought, what can I lose? And I got a bug, and then I was just like laying that at like 11 p.m. I was ready to go to sleep or something. And I got like emails, like 4 emails or 3 emails, because if you get a bug which pays, then you get like a lot of emails because they confirm it, they paid it. That's like, so I just like look at my phone, and it was buzzing like, and I got the bounty, my first bounty ever. And it was a crazy feeling. So it's certainly possible. You just have to put in the work and try to do it. It looks really impossible to do that. SQLi not such a big of a program. How much time do I have? Or
if we could, the 2 questions that are there now, if they could be the last, please, if you could answer those.
Okay, so let's just bug hunting. From last summer, so I just finished that question. Slido, I hope it was gonna work out. So SQL not a big of a problem. Yeah, frameworks usually use some kind of to map the SQL database to an object. So you're not actually writing queries, you are doing you're communicating with an object. So that's why they handle all of the queries for you in the background, so you just don't have to write the query and escape and everything. So modern frameworks, yes, they can definitely prevent bugs nowadays. Any issues with law as a result of bug reporting? These systems, in Hungary the situation is pretty rough, in my opinion. I don't recommend to report stuff to programs, or not. You shouldn't test or report or do anything for companies if they don't have a bug bounty program. Just try to skip it. It looks like just such a good thing to, report a bug on a big something system. But if they don't have a bug bounty program, just don't test, and you're gonna be way better later, because you don't want to get into legal stuff. So just try to stay in bug bounties. Time is up. Hi, BKB. Yeah. So time is up. Thank you, Anonymous. I think that was it. So okay. I'm just going to do the final talk. Thank you.
Dávid, thank you very much.